Hey guys, welcome to the second video. So today I want to go over movement logic, starting simple and working our way up. So the first part of the video is going to be more explanatory and I'll be showing you coding examples so that we can compare them quickly, and we'll start live coding after that. I know I mentioned importing assets last time, but it made more sense to separate them into different videos, so we'll do that next time. So just so that we have an end goal in mind, I want to go over what I want our movement system to have by the end. It's going to have 4 directional movement, so the player will move left, right, up and down. We're not going to have diagonal movement. I also want our system to have different speeds so that if we hit the shift button, we'll run a bit faster. And I want us to have a collision system as well. So those are our goals. Let's start at the code that we had in the last video. So remember we were in the step event of the player. So this right here is movement at its simplest, right? They'll just say if I hit a button, then change the coordinate. So there's a few ways that we can refine this from the get-go. So for one, there's a quicker way to write x equals x plus 2. We could just write x plus equals 2. It means the same thing. Or if you're writing x equals x minus 2, you could put x equals minus 2, or you could put x minus equals. All right, so now let's say that I want to change the number of pixels my character moves when I hit a button. So instead of 2, let's say I want to change it to 3. So I could go and manually change all the 2s, but what if I want to change it again later? So we can make life a bit easier on ourselves by using a variable instead of a number, and then all we have to do is change that variable once. So I'm putting SPD for speed. We can't actually use the variable speed because it's a built-in variable in GameMaker. If you type it in a code block, you'll see it go green, and anything green in GameMaker is a built-in variable. So that includes things like X and Y. But anyway, I'm going to put SPD, but you could put player speed or my speed or anything you like. So remember, this code is in the step event, right? It's running every frame. And we need it here because we need to check for input every frame and we want it to be updating the player's position every frame. But we don't need to be declaring our speed variable every frame, do we? So we can actually move that off to the create event because we only need it to run once, just when it's created. Let's refine this a little more. I'm actually going to set up a few more variables and I'm going to make them equal to our keyboard checks. So these variables are storing the keyboard check, which means they'll either be equal to true or false. I'm pressing the button or I'm not pressing the button. And just like with our speed variable, we can substitute these in. And so now, we don't have to do this, but it can be handy to store this variable because if we use it later in the code. For example, maybe I wanted to check if the player was idle and not moving, I might want to change its sprite to the idle sprite. So I could just check if we're not pressing any of our input keys, then I could write that code in there. And it also just makes everything a bit more readable in my opinion, but this isn't really a crucial step. All right, let's move on to collisions. So we'll go into how to actually code a collision in a couple minutes, but for now I'm just putting all caps collision as a placeholder. That's not actual code, okay? This is just to show you the logic. So we could set up our system like this. We could check for the input, move the player according to that input, and if we end up colliding with something, we could move the player back so that it's not colliding with anything anymore. But this isn't really ideal because we've moved the player twice. We've moved it forwards and then we've moved it back because we're colliding. It would be more efficient to just prevent the player from colliding in the first place. So to do that, we would have to be looking ahead. So when we do our collision checks, we're checking if we're about to hit something instead of if we are colliding with something. And if it is going to hit something, we don't want it to move its full movement. Let's say our player's speed is 6 and it's 4 pixels away from a wall. We want it to move only those 4 pixels and then stop right in front of the wall. So to do this, we have to set up the logic for our system differently. First, we check for the player's input. Then we calculate to see how much we want to move. This is kind of our intended movement. Then we check that intended movement to see if we're going to collide. And if it passes, then we apply the movement and only then do we change the player's X and Y coordinates. So in terms of code, our input code, it's the same as before. But now for the intended movement, we're going to set up 2 new variables, move X and move Y. And these are going to be the amounts that we want to move in the X and Y direction. So we'll be putting X plus equals move X at the end. So similar logic to before, if I press X, the amount I want to move, the intended movement, will be equal to my negative speed. Negative because we're going left. And the same goes for all of the other inputs. So next is our collision check. So remember, we're checking here Not if we're currently colliding, but if we're about to collide. If there is a collision, then we're going to set our intended movement back to 0, because if we're going to collide, we don't want to move there, so we're going to prevent the movement in the first place. But if we pass the collision check and we're not going to collide, then we go ahead and we apply the movement to X. So if there's no input, or if we fail the collision check, then move X and move Y are going to be equal to 0, and we won't be moving anywhere. So I'd suggest adding comments to your code at this stage because it's getting a bit more complicated, just so that you remember what each section is doing. And we can add comments by just adding these double slashes at the start of the line. Anything after those double slashes, they won't actually do anything at runtime, they'll just be ignored. So you can put anything you like there. So at this stage, let's just take a minute to think about what we've done. So we've coded the 4-directional movement, but we haven't constrained the movement to only one direction at a time. At the moment, it will still be allowing diagonal movement. If I'm pressing left and the up key, I'm going to be moving up and to the left, so I'm going to be moving diagonally. So to change this and only allow movement in one direction, all we have to do is change our if statements to else ifs. So now these statements are sort of linked together. So when the code runs, if I'm pressing left, the first statement will be true and it will run the code inside the code brackets, but it's not going to go any further. It's not going to check any of the following else ifs. They're only checked if the previous condition hasn't been met. So the only way we're ever going to go up or down is if we're not pressing left or right. So we could leave our code here, it's totally fine, it'd work fine in a game if you have it like this, but there is a slight bias in the movement. So if I'm pressing multiple keys at the same time, you can see because of the way that we've structured the if and else if statements, that left is always going to win. So let me show you. So here I have my player object and some arrows, and these are going to light up and show you which buttons I'm pressing. So if I press right and left at the same time, left wins. And the same goes for up and down. So there isn't really anything wrong with that. Some games actually, they have movement like this, but there is another way that we can code our movement to prevent this problem and to make it so that if we're pressing left and right at the same time, that they cancel and we just don't move. So we can actually get rid of our previous intended movement code and simplify it into just 2 lines. So let me explain these two. They're a bit trickier. So remember how I explained that the keyboard check functions, they return true or false, right? So I'm pressing it or not pressing it, true or false. In GameMaker, true or false, they're actually equivalent to 1 and 0. So if I write 10 multiplied by false, that's going to equate to 0. So these input variables here are going to be equal to 1 or 0. And this means that we can use them mathematically. So here I've got input right minus input left. So that's going to be 1 or 0 minus 1 or 0. So let's work out an example. So let's pretend I'm just pressing the left key only. So this means that input right will be 0 and input left will be 1. So we'll get 0 minus 1, and that will equal -1. And then -1 times our speed will equal negative speed, which is exactly what we want because we want to be moving left. We want to be decreasing our x value. Okay, let's try another one. So let's say I'm pressing both keys. So input right will be 1 and input left will be 1. So we'll get 1 minus 1, which is 0, and then 0 times our speed will be 0. So move x is going to be 0 and we're not going to move. Finally, if we're not pressing any buttons, both input left and input right are going to equal 0. So again, we're going to get 0 times our speed and move x will be 0. And obviously this is all the same for the move y. So our maths works out exactly the same as before, but now we've got our inputs cancelling each other if we're pressing 2 of them at the same time. The only thing is we're back to our previous problem of allowing diagonal movement. So we can move up and we can also move left, so that's allowing diagonal. So to stop that, we can just add a little if check. So we'll only allow moving up or down if we're not moving horizontally. So if move x is equal to 0. So this means that if we're pressing left and then we hit up, we're just going to keep going left. But if we're pressing up and then we hit left, we'll stop moving up and then we'll just start going left. Because the if statement is not going to be true anymore. So if you'd prefer it the other way around, so that there's a bias to moving vertically instead of horizontally, then you can just change those over. Alright, so we're done for the movement. The next thing that we're going to do is write the code for having multiple speeds. So we're going to come over to GameMaker Studio 2. We're going to come over to our player objects create event, and we're going to declare 3 more variables. So these are going to be our walking speeds, our normal speed, and our run speed. And I'm just going to set these equal to 1, 2, 3, but you can have other speeds if you want. As for our speed variable, it doesn't matter what it equals here because we're actually going to be changing this in the step event. All right, so over in our step event, we're going to declare 2 more variables, 2 more input variables. So we're going to have input walk, and we're going to have that equal to the keyboard check for the control key. That's going to be my walking key, and we're going to declare input run, and I'm going to make that equal to the keyboard check for the shift key. So now to alter the speed, we're going to change our SPD, our speed variable, depending on which of the input buttons that we're pressing. So we're either going to be pressing walk, run, or nothing, and so the speed will equal the walking speed, the run speed, or the normal speed. So if we're pressing the input walk, so if that's true, then our speed is going to equal our walking speed. And then else if we're pressing the run button, the speed will equal the running speed. And if neither of those are true, then our speed will just equal the normal speed. And just to make it a little prettier, a little bit more readable, sometimes I like to tab over these, just so that they all line up and I can read it really quickly. Okay, so let's see how that looks. So you can see the speed variable in green here changing. So if we are pressing the run button, our speed goes up to 3. And if we're pressing the walk button, our speed goes down to 1. But the thing is, again, there is a slight bias for the walk. So if we're pressing walk and run, because of how we set out our code logic, again, there is a bias to the walk. So if we're pressing walk and run, it's going to just stop and do the walking because that condition has been met. Okay, so we're going to look at another way to write the speed. So we're going to say if we're pressing the walk or the run button, and we're just going to write this out and I'll explain it once it's done because it's a bit long. So speed value is equal to the absolute value, and that means even if this works out to be negative, it's going to make it positive. And then input walk times the walking speed minus input run times the run speed. So remember that the keyboard checks, they can equal 1 or 0. So we're going to use this again to do a bit of maths. So if we're pressing both the walk and the run speed, input walk is going to be 1. So we'll have 1 times 1. So that equates to 1. And then minus 1, 3. And then that's going to equate to negative 2. And then we're taking the absolute value of that. So that negative 2, that will become a 2. And our speed will equal 2. So by doing this, we're getting the midpoint between the two speeds. And then we can just put otherwise, if we're not pressing walk or run, then just make our speed equal to the normal speed. So now that we've changed our speed code, you can see that if we're pressing walk and run at the same time, it's no longer just defaults to the walk, it's becoming 2. So the midpoint between the run and walk speed. And just to make this slightly more obvious, let's go and change our speeds a bit. So we're going to change the walk speed to 2, the normal speed to 3, and the run to 6. So now if we're running, speed is 6. If we're walking, it's 2, and our normal speed is 3. And if we're pressing both run and walk at the same time, our speed goes to 4. So that's exactly what we want. Okay, and the last thing we're doing is the collision. So before we go any further, let's change something in the project settings. So let's go into options, main, and we're going to change the game frames per second. We're going to change that up to 60. Just so that we have 60 frames per second. All right, and actually before we go any further, we should change our asset names. So it's really important in your game projects to have a good naming organization. So what people normally do is they have a sort of naming strategy. So they have all of their sprites begin with the prefix SPR or S or something like that, and then whatever the sprite is of. So SPR player. And then for the objects, all of the objects will have a prefix OBJ first and then player. Because we can't call them both player, you can't have 2 assets named the same thing. GameMaker is going to complain, and if you ever reference that name, GameMaker isn't going to know which one you mean, and there's going to be a conflict. So you have to call them something different. And for room, we'll just call that RM0. All right, so let's come into the player object. So this is the code that you should have right now in the step event, and in the create event, here's what we have. Actually, I might just change the speeds back to 1, 2, 3. That's going to look a bit better for our RPG game. So for our collision, we're going to be creating a new object. So we're also going to need a new sprite. So let's go over to, actually, we can just duplicate the player sprite and we'll call this SPR collision. And we'll come into it and we'll just make it a different color. So I'll make this red. So while we're here, something important for collision is an object's collision mask. And this it defines where on the sprite we're going to be checking for the collision. So we don't have to check for collisions on the entire sprite. We could just check for a certain area. So we can manually change what's called the bounding box of the sprite to be something different. But for now, we'll just make it equal to the entire sprite. Another thing to note is the Sprite Origin. So this is where your object is going to be anchored in the game world. So if it's at the top left, when you place the objects, that's where the object is going to be anchored to. In our game, we'll probably be changing these to be the bottom center where the character's feet is, but for now we can just leave it at the top left. So we're going to create the collision object. We're going to call this obj collision. And we're not going to do really anything in here. We'll just assign it the sprite that we made. And we'll head back to the player object, into the step event. And we're going to actually be coding the collision now. So we're going to get rid of this. And we're going to have two collision checks. We're going to have a horizontal check and we're going to have a vertical check. And this is for our moving X and move Y. So the code that we're going to use for GameMaker for a collision is called a place meeting. So it's checking if two objects have overlapping boundary boxes. So we're going to type if place meeting. So if there is a place meeting at our X position plus move X, because we're checking where we're going to be, not where we are, right? So X plus move X, Y, and then the objects that we're checking for a collision with is with obj collision. So this function is going to return either true or false. So if there was a collision, it will return true, and then the code inside these brackets is going to run. So for now, let's just put move X equal to 0 so that we stop the movement. And let's come into the room editor, and I'm just going to get rid of some of these player objects. We only need one. And I'm going to drag in a few collision objects. And just to note, you can only drag in objects into the instances layer. So you can't drag them into like a background because it's not the appropriate asset type for this layer in the background layer. And we put all of our instances, all of our object instances into the instances layers. Although you can have more than one instance layer. All right, anyway, let's just create a little level for our player. So you can click and drag on these objects and stretch them, make them a bit bigger. All right, that'll do. Let's run the game. All right, so we can see that our code is working. Our player stops, but you can see there's a little gap between the player object and the collision object. And it's okay at this speed, but at higher speeds, it's going to be leaving a bigger gap. Let's just change the running speed to 10. So you can see it's leaving quite a noticeable gap here. Whereas the desired movement for us would be stopping right next to the collision object. So let's just set the speed back and we'll come back into our step event and we're going to alter the collision code. So instead of just setting our move X to 0, we're going to do something a bit more sophisticated. Basically, if this turns out to be true, if we are going to have a collision at X plus move X, the next thing we're going to do is check if we just have a collision one space away from us. And if there isn't a collision there, then we're going to move closer to it. And we're going to keep doing that until we hit the edge and then we'll stop. So we're going to go if there isn't a place meeting. So if there's not a place meeting at X plus the sign of move X. So this is going to get 1 in the direction that we're heading. So either -1 if we're moving left, if move X is equal to negative speed, or +1 if move X is 1 and we're moving right. So if there's not a place meeting at X plus the sign of move X, and then we just put Y and object collision, and then we're going to move X to that position because that spot is free. So now we can't just do this once. We're going to have to repeat this code as many times as there are spots free to move to. So we're going to repeat, and the number that we're going to repeat by is the absolute value of our move X. So whatever our speed is. But obviously we don't want to be using negative speeds. And we're doing this also to account for different speeds. So if we're walking or running, this code should still work. So we keep checking for places free. And if we do find a place free, then we can come out of this repeat loop. If there's only 4 spaces free, we don't have to repeat this 6 times. So if we find that there's no longer a free place, then we're going to put break, and that will stop the loop and we'll come out of it. And because we've been altering X directly, we don't want any more input from our intended movement. So we want to set move X to 0 so that it isn't moving, because we've done all the movement ourselves through the collision system. So, and because this code is kind of bulky, so sometimes what I like to do just to neaten up my code and reduce the number of lines, I might just put it on the same line as the if condition, just like that, just to make it a bit shorter and a bit easier to read. But you don't have to do that. If the other way makes more sense, then just leave it as it is. So now we can just copy and paste this horizontal collision check, and we'll just alter the variables to make it appropriate for the Y. All right, so we're done. Let's have a look at that. Let's move around. So you can see that it's working and it's coming right up next to the collision blocks. And this is the behavior that we want. It's pixel perfect collision. So one little thing that we can do to make this system a little bit more efficient is that these collision checks, we don't actually have to be executing them all the time. We only have to be checking for collisions if we're moving at all. So before the collision check, we can actually put move X is not equal to 0. Then that means that we're moving. So if we're moving, then go ahead and do the collision checks. So we can wrap this whole thing in this if statement and just tab it forwards. And we can do the same for the vertical. And this will stop running unnecessary code. So it'll make the whole thing a little bit faster. It's only checking for collisions when it has to. All right, so we're finished. We've got our movement system and a collision system in place. In the next video, we'll definitely start importing actual assets and making our game a bit prettier and having a bit more fun. But I wanted to get this down and out of the way because it's really important to the foundation of the game, and it's good to consider different methods for movement because there's literally infinity ways to code something, and it's just going to depend on what you want out of the collision system and what's most appropriate for your game. So I hope that's helped, and I hope to see you in the next video. Bye guys!